Welcome to this workshop skills video. Our topic in this video is workshop cutoff machines. Workshop cutoff machines are probably the very first machine that we would use in a general manufacturing process. They're the first machine we would go to. The machine we see here is a horizontal bandsaw. Pretty common piece of equipment. Before we do that, let's have a look at how the materials are stored and accessed for use. The steel that we're going to cut up is generally stored in a steel rack. That way it's nice and safe and accessible. Easy to see the sizes of materials like we're measuring there, so we can select the piece we require. We have all sorts of shapes and sections of steel in use in the industry. Here you see some of them. There's a piece of aluminium bar, thin wall pipe. There are many types of pipe in use, from water pipe, steam pipe, hydraulic tubing, copper tubing, and many other types. 19mm square, bright mild steel bar. This is a piece of high-speed steel. It's very hard and can be used to make cutting tools out of for cutting mild steel. A section of hexagonal brass, and lastly a piece of bright mild steel round bar. Common in all workshops in different diameters. So the first thing we need to do is have a look at the drawing and decide what size of material we need to select from the steel rack. And we can see from the drawing that the diameter of the bar we require is 40mm. So it's 40mm diameter. The length, we'll need to cut it at least to 74mm long. The drawing is our specifications and dictate exactly what we must machine and manufacture to. So we're back with our bandsaw again. Horizontal continuous blade bandsaw. And what we need to do here is measure off our 74mm. Just resting the end of the rule up against the blade, and then measuring from there back to the end of the bar, just positioning the bar where we require it. If we zoom in on that, you'll see that we've actually set the saw blade to a distance of 76mm. We allow a little bit extra just for cleaning up when it comes to machining, and for any discrepancies which may occur when setting the workpiece up in the bandsaw, because we may get it a little bit shorter than the size we intended. And if we do, we've got a little bit of excess there, which will allow for a bit of error. Start the machine up. And the frame of the saw is lowered using hydraulics. Got a hydraulic cylinder on there, and we can control the speed at which we allow that blade to come in contact with the workpiece. And we've got to set a nice steady cutting speed on that. And as you can see here, it does a very efficient job. We're also using coolant on this blade just to keep things nice, and keeps the blade cool, keeps the workpiece cool, and it also just helps with the cutting process, to lubricate the cutting process. once we've cut the workpiece off, we just lift the saw frame back up to its starting position again and just remove our cut off section of steel. Here we're looking at another bandsaw. This one's got an automatic return, so there's no need to raise the horizontal frame up by hand. It will do that automatically. And you can also see that it's got a conveyor there, so it's got a materials loading conveyor on the left hand side, so that all the materials to be cut can be laid out there and easily brought along to the saw blade. Very handy if we want to cut a lot of pieces. We want to cut 50 pieces or 100 pieces. You can see it automatically returning there. It's also got a hydraulic vise on it. The vise will open automatically. Here we see the blade just almost completing the cut. Plenty of coolant being applied. Gives a good cutting life on the blade. And once it goes through the workpiece, it returns to a starting position. Notice we've got a stop set up there too at the end of the workpiece, so if we had another piece to be cut, we just simply take that one away, slide the bar along until it touches the stop. That positions the bar for the next cut to be taken. So multiple pieces can be cut quite easily by setting stops on it. Always keep safety in mind. Keep your hands away from working machinery. Never put your hand near the job to try to reposition it once the blade started cutting. Don't try to adjust the vise by loosening it or something. Cause the blade to break and perhaps damage to the operator as well. The blade is just returned to its starting position, and we can remove the piece of material. What we're doing here is that we were trying to cut a short piece of stock or material which isn't long enough to completely fit along the vise and give it a good substantial gripping power on it. What we can do is get us another piece of steel, similar section, put it in the other side of the vise. And this will allow the forces on the vise to be balanced up so that it gets a nice even pressure on the short piece of steel on the cutting side of the vise. If we don't put that other piece in, the vise will be skewed and it will only have a single point contact on the workpiece, and it's very easy for it to break free with the cutting forces and the load of the blade and so on. So always make sure you put that other piece of steel on the opposite side of the vise. Make sure it's a piece with the same section if you've got it, or very similar. Here we're looking at a reciprocating hacksaw. There are many of them in use, and they have been around for many, many years, but they're still a reliable and efficient piece of cutoff machinery. Just looking at the stop switch there, fairly simple but effective. When the frame of the saw comes down, makes contact with that stop switch, obviously the power to the blade is stopped altogether. Once this saw is put into operation, make sure that your head is not in close vicinity of the ram or the frame of the saw. So stand clear when you're operating that. And again, it's hydraulically fed down into the workpiece, just slowly coming down. And there's generally an adjustment on that so that we can make it come down faster or slower depending on what materials we're cutting. Also stick it with coolant if you're doing a lot of work. Production jobs to be cut off. Then making sure you've got a good flow of coolant is necessary. In this case we're cutting a small piece as an example, and it looks like we're out of coolant, so to replenish it we just need to get a bucket of cut coolant and just put it into the tray there beneath the blade, and it will make its own way down to the sump, and then start recirculating via a small pump that's inside the machine there. Here we're looking at an abrasive cutoff disc. A couple of things about them. One, they can be very noisy, and of course with the disc too, it's important that you check the disc and make sure that there are no cracks or no chips in it. Just checking other bits of machinery there before we start operating it. It's got a half nut setup on this vise which allows for quick movement, as you can see, or quick release. So you can get the vise jaw in and out very quickly to position the workpiece to be cut. Just having a look at the disc to make sure that it's in good condition. You have to be careful of that in a workshop because you don't know who's been operating the saw before you, and it may have been damaged, or they may be about to change the blade or change the disc in this case because they've noticed a crack or maybe damaged it in operation themselves and are about to change it. So just make sure that the disc is sound and ready for use. All the details and information, if you do have to replace the disc, are written on the center of the hub there, as you can see. Gives you information like what metals you can cut with the blade and what sort of RPM it should spin at and so on.
Some industries, they require you to wear double face protection, so you need to wear safety glasses and a face shield. So before I put that on, what I'll do is I'll put the piece of high-speed steel in the vise.
And here John is preparing a piece of high-speed steel. It's very hard, and so we couldn't cut that on a bandsaw, or the horizontal bandsaw that we were using a few minutes ago. So this is where this abrasive disc comes in very handy for cutting hard materials. Beware of hot workpieces. This will be very warm now.
The material will be incredibly hot when you finish too, so just be careful with handle that will be good.
You can see a nice clean cut there, like a grinding cut. Now we're looking at a cold saw again, like the abrasive disc saw we saw before. This one has got a large circular disc on it, but in this case it's got teeth all around the outside or the periphery of it. It's called a cold saw. We'll have a close-up of it and you can see the teeth on it. Just clamping a piece of bar in here into the vise. There's a cutter made out of high-speed steel, very hard material. And a series of saw-like teeth around the circumference of the blade. We just feed that nice and slowly. And you notice John was holding that or feeding it by hand, so you're gonna, it's manually controlled, and you just slowly feed that down into the workpiece. And each tooth takes a little chip of steel out until we get right through the job. Check the standard operating procedures attached to the machine. If you have any difficulty with it, ask someone to show you the correct operating procedure. Here we're looking at a guillotine. And guillotines are generally used for large plates of steel of various thicknesses, from very thin to very thick machines, or very thick materials. The thicker they are, the more powerful the guillotine needs to be to handle that sort of work. If we have a lot of pieces to cut off, we have backstops on the guillotine. You can see them being adjusted there. The motor is turning and you can see that yellow rail moving backwards, so it can move to whatever distance we need, so that we can cut a lot of pieces of material relatively quickly by just feeding them in until it hits a stop, and then bringing the guillotine blade down to shear it off. Notice too, it's got a foot pedal there that he's just going to press to depress bring the blade down. And so that gives you a little bit of remote operation, which allows you to keep your hands free so you can use them for positioning the workpiece and so on. Obviously you've got to keep your hands well clear of this. It's a well guarded machine, but nevertheless keep your fingers out from underneath that guard, that yellow guard. There you can see the type of sheet metal that he has just cut on that. You'll notice too, even though you may not get your fingers into the blade, if you look carefully there, you'll see one of these holding rams or pistons that come down and clamp the workpiece. And they can do a lot of damage to your, because they're hydraulically operated, and they will certainly do a lot of damage to your fingers if you get caught underneath them. So stand clear and work safely. Here we're looking at a sheet metal type of cut-off machine with something that resembles, I guess, a nibbler's type of cutting head on it. And if you just watch your feeds that through and it shears it off quite nicely and quite easily. Notice here he's starting at the inside and working out. You would need to be a skilled operator to do something like that. And he's turning it around in a circular fashion just to show that we can cut circles or circular shapes out of it as well as straight lines. And if you look here, he's doing a sort of an S bend on it, or a random curve shape. And so obviously a very useful and flexible type of cutoff machine. But on a machine like this, it's important that you have adequate instruction before you will start to use it. A lot of damage could be done to the machinery and to the operator if he's not correctly skilled. Here we're looking at something a little different. It's not so much a cutoff machine, but it's the same type of machine being used for a different process. Here we're making a dished type of shape, a concave shape, using these two heads that come together and act like a automatic hammering machine and start to stretch or hammer that steel into this dished type of shape. Again, it requires a skill and a knowledge of how to operate this machine and know all the adjustments on it. So make sure you're well instructed in the use of it before you would use it. You can see there how that's just been shaped out nice and smoothly too. So thank you for watching this video on cutoff machines.